Hello everyone, welcome to another education video, and today this is the third part 3 of the solid principle in Java programming. And the third last time we discussed about SRP, which is single responsible principle. Then we discussed the open closed principle. Then we discussed Liskov principle. The fourth one in the total 5 principles under solid are the integrated segregation principle. What are the significance of interface segregation principle? Let's first look into the PPT. ISP suggests that the client should not be forced to depend on interfaces they don't use. By adhering to this principle, interface become more focused and tailored to specific clients, preventing the problem of fat interface or interface pollution. If you might be aware of the term interface pollution, that requires implementation of unnecessary method. This leads to cleaner and more maintainable code, meaning uh, in order to make our code more cleaner and more maintainable, it is important to segregate our interfaces smartly. Segregation is simply a term that we divide the interfaces in such a way that the interface contract does not grow larger in size, and the classes or the concrete classes extending to this interface or to these contracts are uh, not implementing those methods which are not required in the context of that class. So the client should not have unnecessary dependent upon those interface which it does not use, and in order to uh, make sure this thing does not happen, a principle is followed, which is we're discussing right now, is an ISP. Now, what are the signs of interface pollution? Many times in a code, in most of my work, I have experienced or I have seen there are a lot of cases where methods are are having empty implementation into the interface. That is the one reason sign of an interface pollution. Many method implementations throw unsupported operational exceptions, and method implementation return null or default or dummy values. So these are some of the signs of interface pollution, and in the further video we will look at what are the steps to avoid this, and we'll try to figure out identify the sign of interface pollution, and then do code retrofit to fix this issue. And many in the further, let's move on to the further coding example. So I have let's create the package for ISP interface segregation principle. ISP. I have some coder with me. I'll just copy those code. There is a service package, and I have two service class. Let's create a service package. Add the code over here. Then we have two generic classes, which is under entity package. Let's create a new package under ISP entity. Copy this code over here. So let's first look into the code. Let's first step one is to identify if there is any pollution or interface pollution happening. So we'll see firstly the here we can see right now the code is entity. It's an abstract class with three method, one property and two get and set method, and order and user classes are there. They basically extend to the entity class. So here we can see we have created a base entity class, and which will be extended by our order and the user class. Why we create a abstract class and extend it is the reason of flexibility. Certain properties under any business domain is are common, like for every order and every user there is an ID. So instead of defining them within the property or as a attribute under each class, it's better to use the functionality provided by extension, that is create a class, and then we can then extend it to the entity base class. That's with our classes are. Then we have a service, and the persistent service can be extending to any, can be a persistent service can be extending to any, like it can be to any JPA repository or any repository class or DAO class. So here in this we are taking a simple example. I'll just have a public interface called persistent service, and then it will be having few contracts like save, delete, few common methods. Then we have a user persistent service, and here we are implementing that persistent service, and the user will be our entity object. So here in this case I'm directly using a hash map, but your application or your client can be using a database, and the database can be using JPA repository or data access objects, DAOs. So here I've just simply use a hash map. I'll just go ahead and fix some of the errors that we are having. This user class is not found. Let me import the fix issue. So utility hash map integrate. This should be ISP, and this also is an error because we renamed the package. The package is not correct. It's under ISP code. So now this should fix. Yeah, now the errors are gone. Here we can see the errors are gone. So basically what we are doing here is, there is a persistent service. We have segregated an interface, that is this one, and it has certain contracts, and the user persistent service will implement those contracts and give the implementation methods and as an override methods. That's, we already know the basics of it. Now let's go ahead and create an order persistent service. Let's create an order persistence service. This will be a class which will implement persistent service order the persistent services of type order. Let's import the order class, and under the order, if you see, we need to define a method. We need to define a hash map again. Yes, in this case we are using the hash map data structure. You can even use this to connect to your JPA database via JPA repository and call in the SQL statements for data access. So here we'll call this this to order, and just call this orders. This is already import this class order and user. So this, there is a red squiggly down there because we need to implement those methods. I'll quickly go ahead and implement those methods, and we'll copy paste some of this access to hash map. So this is an overridden method which will have an access to the hash map information that will provide, and this will be to save, this will be to delete. So this will be basically, sorry, copy, this will be to remove, I think so, hash method remove. Then this is to find, so find will be a get method of the hash map data structure. Just give a get with an object key, save dt.get id. So now we've done all the implementation from the persistent service from the interface. Well, when we see there is a additional find by method which is sourced from our persistent interface, and when we look at our order class, we don't have any name property called as name. So basically, there is an interface solution happening in this, violating the principle of ISP, that the order processing service is implementing product, but the order object or entity doesn't have any property while with find by name. So this basically is find by name is a redundant property and redundant method in terms of this. So this basically is an example, good example of so interface pollution. So we'll have to smartly segregate this interface. So let's now retrofit this code, fix this. Firstly, we will throw new find by name. We'll throw an unsupported operation exemption. Name method name is not supported yet. Not supported, and we have an error over here. Orders.get orders.remove. Okay, the method was missing a return null statement, so that's done now. Basically, it should return an order, so there should be an order over here, and the null should not be present. So with this, we have fixed this code, but this this method should not be part of an overridden method. So what we will do is, firstly, we will go to persistence, persistence. So we need to segregate this interface. So instead of segregating this incident, uh, we will the persistence. So there is no scope of further segregation, but we can comment out this method as it is not used, and instead of throwing an unsupported method, we should remove this method. No required, so we'll simply remove this method, not required over here. And the persistent service also will remove this contract of find by name, and then there will be an issue with user persistence because it's still. So for fixing this, we'll just remove an override method and use this as its own method under user persistence service. So this is how we can identify the pollution of interfaces and also smartly segregate the interface so that the code is more cleaner and more maintainable, and preventing the problem of fat interface that we usually encounter in many of the software developed. So this was one of the fourth principle under solid called interface segregation principle. So if you have any other doubts, please let me know in the comment section, and we'll be meeting for a next video that we'll discuss is the fifth one and the final one, the dependency inversion principle. So if you have watched till now, thank you for watching the video, and please let me know if you have any doubts or need any other further explanation to this principle. Thank you for watching the video. Have a nice day.